This is the drill factor theorem review. And let's just go through and we'll try each one of these. It asks us to factor 3x squared minus 13x minus 10. So since the leading coefficient is greater than 1, I can use slide and divide. And I get x squared minus 13x minus 30. When I go to factor this, I'm going to use the diamond method. And I need to think of my factors of 30 that add up to negative 13. I know that would be negative 15 and 2. So I get x minus 15 and x plus 2. Then now I wish I could just be done, but I wasn't asked to factor this, I was asked to factor this. So then I have to unslide this 3. Since I multiplied it, when I slid it, I have to unslide and divide. So divide by 3. Next I need to simplify. And then I need to move that denominator. So there's my answer, x minus 5 and 3x plus 2. So this was all my work for number 1. Let's do the same kind of thing for number 2. Because I have a leading coefficient that's greater than 1, I'm going to slide that. And I get x squared plus 8x plus 12. I'm going to factor that. I need to think of my factors of 12 that add up to 8. And I know that that's x plus 6 and x plus 2. Wish I was done, but this isn't what I was factoring. I was factoring this. I multiplied by 4, so now I have to divide by 4. Simplify. And then I need to unslide my denominator, so I get 2x plus 3 and 2x plus 1. This doesn't have a middle term, which means I need to figure out how I can get a product of negative 49 and a sum of 0. Well, I know that if I have a positive 7 and a negative 7, I would get a sum of 0 and a product of negative 49, so my factors are x plus 7 and x minus 7. Factoring x squared minus 3, are there any factors of negative 3 that add up to 0? There are not, just 1 and 3. So this just has to, this is not factorable. I mean, technically you could say x plus the square root of 3 and x minus the square root of 3. Because when you multiply them by each other, you get 3, and their sum would cancel, but normally we'd say it's not factorable. Number 5, find an equation for a polynomial with these zeros. Well, if negative 2 is a 0, x plus 2 is a factor. Negative 3/4 is a 0, then x plus 3/4 is a factor. 9/2 means x minus 9/2 is a factor. I'm not going to leave this 4 and this 2. I have to put those in the front. So my factors are actually x plus 2, 4x plus 3, and 2x minus 9. So now I need to multiply these all together. I'll start by doing this, and I get 4x squared for my first terms. Outers, I get 3x. Inners, I get 8x. 3x and 8x is 11x. 2 times 3 is 6. And I'm going to multiply that by 2x minus 9. Right? So then I need to multiply these. So I'm going to take this 2x and distribute it to all three, and I get 8x cubed plus 22x squared plus 12x. Then I'm going to distribute the negative 9 to all three, and I get negative 36x squared minus 99x minus 54. So I get 8x cubed, and what would this be? Negative 14x squared, negative, would that be 87? 87? Yes, x minus 54. And number 6, find the zeros. I'm going to see if I can factor this, and if not, then I'll put it in the calculator and look for the zeros. First thing I do is pull out an x, and then I'm left, if I divide each of these by x, I'll put 2x squared plus x minus 3. I'm going to see, well, I'll just stick with slide and divide, because that's what you guys are used to. Pull that 2 over to here. I get x squared plus x minus 6. So I'm looking for the factors of negative 6 that add to 1. With 3 and negative 2. This is x plus 3, x minus 2. But because I multiplied by 2, I now have to divide by 2. Simplify. This first one can't be simplified. This one can. Slide that 2 over, and I get 2x plus 3, x minus 1, and remember I need to bring this x down. So here are my factors. So in order to find the zeros, x for this one would be set equal to 0, it's just a solution. 2x plus 3 must equal 0, and x minus 1 must equal 0. Subtract 3. Divide by 2, add 1, and there are my zeros.